Okay, this is section 4.2 on constructing arithmetic sequences. You should have your notes already glued into your notebook before you start watching this. If you haven't done so yet, go ahead and pause the video first. Finish gluing your notes on your notebook or finish getting ready with your notes, and then go ahead and start the video. Okay, let's get started. So let's start as always by highlighting our essential question. What is an arithmetic sequence? There's a typo there, I just noticed it. It should say what is an arithmetic sequence. Okay, so that's what we're going to be figuring out today, what arithmetic sequences are. Yesterday we talked about sequences in general, not arithmetic sequences. So today we're looking at a specific type of sequence called arithmetic. Okay, so to start, we're going to look at this problem right here and try to figure out all the information that we can figure out from that problem using what we learned yesterday. Okay, so here we go. It says you can order tickets for the local theater online. There is a fee of $2 per order. Matinee tickets cost $10 each. The total cost in dollars of ordering n matinee tickets online can be found by using C of n equals 10 times n plus 2. The table shows the cost of 1, 2, 3, and 4 tickets. Actually, the table doesn't show anything. We have to figure that out, okay? But it's asking us to figure out the cost for 1, 2, 3, and 4 tickets for this function right here, C of n equals 10 n plus 2. So we're going to fill it in for 1 ticket, 2 tickets, 3 tickets, and 4 tickets. So we're going to use a little bit of math and maybe actually mental math like we were practicing yesterday. First thing I'm going to do for 1 ticket is I'm going to plug in 1 right here, right here. So you can do this in your head. C of 1 is what we're doing equals 10 times 1 plus 2. 10 times 1, that's 10, plus 2 is 12. Your first number, the cost for 1 ticket is 12. 2 tickets, that means take 2, plug it in right here. Right here, same function, right? 10 times 2 plus 2, that's 10 times 2, 20. 20 plus 2 is 22. 22. Let's go to the next one. 3. 10 times 3 plus 2. That's 30 plus 2 is 32. And the last one, 4. 10 times 4 plus 2. 10 times 4, that's 40, plus 2 is 42. There you go. So the values for 1 ticket is 12, for 2 tickets is 22, for 3 tickets is 32, for 4 tickets is 42. Next part is identifying the domain. So remember, the domain means the x values. In this case, we don't have x values or y values, but the domain is still the input values. So the input values is the number of tickets, right? The input values is basically the position number of the sequence. This is a sequence, 12, 22, 32, 42. Position number 1, 12. Number 2, 22. Number 3, 32. Number 4, 42. The domain are the x values, the input values. So it's 1, 2, 3, and 4. Range. The range are the y values or the output values. So 12, 22, 32, and 42. There you go. You have your domain, you have your range. The next part is over here where it says find the following: f of 1, f of 2, f of 3, f of 4. Remember what we discussed yesterday. When you guys see this f of 1, if we're talking about a sequence, which this is 12, 22, 32, 43, what you want to do for f of 1 is say what is the first term. F of 2 means what is the second term. F of 3 means what is the third term. F of 4 means what is the fourth term. That's what those things mean. Okay, so f of 1, what is the first term? 12, right? So that first answer should be 12. F of 2, what is the second term? 22. And so on. F of 3, what is the third term? 32. And finally, f of 4, what is the fourth term? 42. Okay, there you go. Your first term is 12, f of 2 is 22, f of 3 is 32, f of 4 is 42. Okay, it means in this situation, this means the first term, the second term, the third term, the fourth term. But really, in this situation means how much for one ticket, how much for two tickets, how much for three tickets, how much for four tickets. That's what these numbers represent. Finally, let's answer this question. What is the difference between two consecutive terms? Consecutive terms as in these terms, right? The first term is 12, the second term is 22, and so on. What is the difference between each consecutive term? So basically, from 12 to 22, what's the difference there? 10, right? It went up by 10. What is the difference between 22 and 32? Also 10. What is the difference between 32 and 42? Also 10. The difference between two consecutive terms is always going to be 10. That means that now I can find the next term by simply adding 10. I don't have to plug in 5. I know that the next one is going to be 10 more, so it's going to be 52. And the next one is going to be 10 more, so it's 62, and so on. I don't have to keep plugging in numbers if I see the pattern. Okay, so let's move on to the next part. In the next part, what we're going to be doing is we're going to give you guys a sequence like this one here, or like this one here, like this one here. This is a sequence. And the challenge is going to be today to figure out what the rule is for that sequence. So yesterday we learned about explicit rules. This is an explicit rule. So I give you the rule and you could tell me the first four terms. We're going backwards. We're going to see if we can take the sequence and figure out what the rule is. So let's move on to the next part. Alright, so the first thing we're going to do is fill in the blanks right here. It says in an blank, the difference between consecutive terms is always equal. What we're talking about here is basically the title of today's lesson. In an arithmetic sequence, that's what I want you guys to put here. Arithmetic sequence. In an arithmetic sequence, the difference between consecutive numbers, consecutive terms, is always equal. Meaning that, like the last one we saw, the difference between these two numbers was 10, 10, 10, right? Every time the difference between them is 10. So if you get the same number every time, you have what we call an arithmetic sequence. So that one right there is an arithmetic sequence because the difference between them is always equal. That number, that common difference, that difference between them that is always the same, has a name. It's called the common difference. So difference because that's the difference between the two numbers. Common because it's the number that they all have in common, right? Between two terms, they all have that 10 in common for that last example. Okay. So in an arithmetic sequence, the difference between the two numbers, consecutive numbers, is always the same. And that number that you find that is the same number for all of them is called the common difference. We're going to use that information to try to figure out what the rule is for these problems down here. Okay, here we go. Number one. The idea here is that I give you a table or a sequence and we try to figure out what the rule is that describes that table. Okay, so what we're going to start with is by writing out the all of the different values that we have here in function form. So here's what I mean. I'm going to write this out. I'm going to write f of 1 equals 2,000. Which is true, right? F of 2 equals 2,500. F of 3 equals 3,000. And so on. Let's write them all. I'm going to leave space here so I could continue over here. F of 4 equals 3,500, 3,500. And F of 5, the last one, is equal to 4,000. Okay? You can see right away, I hope, what it's changing by, right? What is it going up by? And you should be able to see that from 2,000 to 2,500 to 3,000 to 3,500 to 4,000, it's going up by 500. Okay? What I want to write now is write what's happening to each one so that I can figure out what the rule is. So for example, for the first one, 2,000, where did that come from? Well, it just came from the initial amount, right? The savings account says that it begins with 2,000. So that equals 2,000, and there was no change in it. So I'm just going to say it equals 2,000. It hasn't changed at all. But the second one is the 2,000 that you started with plus what? 500, right? It increased by 500. Okay, let's leave it like that. Let's go to the next one and see what happens. The next one was 2,000 also plus 500 plus another 500. So notice what's happening. Each one below is an extra 500, right? This one is the same as that one plus an extra 500. This one is the same as that one plus an extra 500. And that's going to keep going. If I keep going through over here, it's 2,000 plus 500 plus 500 plus 500, right? So I'm going to write them all there so you can see the difference between. Plus 500 plus 500 plus 500. And the last one is exactly the same as that previous one plus an extra 500 there. So it's 2,000 plus how many 500s? 4 of them, right? 500, oops, plus 500 plus 500 plus 500. There you go. 2,000 plus 500 plus 500 plus 500 plus 500. Okay, now what I want to do is look at them and see what's happening to see if I can come up with the rule. Okay, so we're going to clean it up to make it a little nicer to see. The first one is just 2,000, right? You're not adding 500. But if you could write it as plus 500, it would be plus 500 times 0. But for that one, we don't worry. This one has 2,000 plus 500, only one of them. This one, let's clean it up. 2,000 plus 500 plus 500. How many 500s are there? 2. So it's really 2,000 plus 2 500s. Let's actually write the 500 first. Plus 500 times 2. Let's do it the same thing for the last two. This one is 2,000 plus 500 plus 500 plus 500. 3 500s. So what I'm going to write instead is 2,000 plus 500 times 3 because there's 3 of them. Next one, 500, 500, 500, 500. That's 500 times 4. Alright, based on that, I think we can come up with the rule now. This one right here, it's also 500 times something. But since it's just one 500, it's really 500 times 1. So let's put that one there. And the previous one, the 2,000, if I wanted to make them all look the same, if this is 2,000 plus 500 times 4, 2,000 plus 500 times 3, 2,000 plus 500 times 2, 2,000 plus 500 times 1, then this one would be 2,000 plus 500 times 0, right? Because you're not really adding 500. But now they all look the same, and that's what I want. I want to see if there's a pattern in all of them so that they all look the same. And now I can see it. Look at the position number, which is 1, and the number that you're multiplying by, which is 0. The position number is 2, but you're multiplying times 1. The position number is 3, but you're multiplying times 2. See the pattern there? Whatever the position number is, you multiply 500 times 1 less than that, right? 4. Position number is 4, this is 3. If the position number is 6, it would be 500 times 5, and so on. Now we're ready to write the rule. So pay attention to how I'm going to write the rule. Whatever the position number happens to be, let's call it n. I can figure out what the term is going to be by simply writing 2,000, right? They're always 2,000, plus 500, it's always plus 500, times a certain number. What number is that? It's not the same number as the position number, so I can't say it's n. It's always one less than that, right? If the position number is 5, then the number is 4. If the position number is 4, then the number that you're multiplying by is 3. And so on. 1 makes 0. 2 is 1. Always one less. What is 1 less than n? What we write in there is 1 less than n is n take away 1. Whatever n is, take away 1, that is the position, the number that you're multiplying by. That's your final answer. Okay, and don't worry, I'm going to do that again for the next one so you guys can see exactly how we worked on it. We're basically developing a rule that matches this function right here, this table. This rule matches that table right there, because now I can figure out any term in my table by simply plugging in the position number. So if I want to find the 20th term, I would plug in 20 right here, and so on. Watch as we do it again. The table here shows the monthly balance in a savings account with regular monthly deposits. First thing I'm going to do before I start writing f of 1, f of 2, and so on, I'm going to try to figure out what the common difference is. What is the difference between terms here? So from 5,000 to 6,000 is 1,000. From 6,000 to 7,000 it's 1,000. From 7,000 to 8,000 it's 1,000. From 8,000 to 9,000 it's 1,000, right? Every single one of them is being added by 1,000. So here's what I'm going to write. I'm going to write f of 1 equals, I know what f of 1 is, right? The first term, 5,000. Just 5,000 by itself. F of 2 equals 5,000, the original number, plus an extra 1,000 on top of that. Right? You guys agree with that? This is 5,000. The next one is 5,000 plus 1,000. I want them all to look the same, remember? F of 3. That's 5,000 plus 1,000 plus another 1,000, right? Because it's 5,000. F of 3 is 6,000. I mean 7,000. So it's 5,000 plus 1,000 plus another 1,000. But I don't want to keep adding 1,000. I'm just going to say since there's two of them, it's 1,000 times 2. Just follow? So that means that in this one that I skipped up here, I mean that I did, but I didn't multiply times anything, I am really multiplying the 1,000. I'm multiplying it times 1. Same thing for the top one. It is 5,000 plus 1,000. Remember, I want them all to look the same, but it's just 1,000 times 0. See how they all look the same now? And they all make sense. F of 1 is 5,000, because 1,000 times 0 is 0. F of 2 is 5,000 plus 1,000, 6,000. F of 3 is 5,000 plus 2,000, which is 7,000. We can now figure out the other ones. F of 4 is 5,000. Remember, I want them all to look the same. Plus how many 1,000s? 3 of them. Right? Because it's 8,000 total. F of 5 is start with 5,000, but then on top of that, 4 1,000s to make it the same. Now if you look at all of them, they all look the same. They all follow the same pattern. Right? 5,000 plus 1,000 times 0. 5,000 plus 1,000 times 1. 5,000 plus 1,000 times 2, and so on. Notice again, compare the position number to the actual number you're multiplying by. If this is 2, this is 1. If this is 3, this is 2. So if my position number is n, so that I can come up with the rule, if my position number is n, what is the number that I'm going to be multiplying 1? Always one less than that, right? So n minus 1. So it's going to be 5,000 plus 1,000 times n minus 1. And that's the rule. We found the explicit rule. Okay? Look at my example, look at your work, make sure you're copying all of this down so you guys can see exactly how I worked it out, because the goal in your problem that you're going to do right now is to find the rule, like this one right here. Find the rule by looking at the table. So if you have to rewind the video and watch it again, or just look at the work and see how it worked out. You started with 5,000, and then the common difference, the difference that it's going up by is 1,000. In this one we multiply times 0 because we're not adding anything. In this one we multiply it times 1 because we're only adding it once, and so on, right? And then we came up with the rule that this number and this number always this number is always one smaller than that one. So it's always going to be n minus 1. All right, go to your side and try problem number 1. Right here. The table shows the number of plates left at a buffet after n hours. Write an explicit rule for the arithmetic sequence represented by a table. Go for it. Look at the work that I just did, and you should be able to figure it out. Okay, so try it. Take like, let's say 4 minutes. Take 4 minutes to try to work it out. See if you guys can figure out what the explicit rule is. Pause the video right now, and then once you're done with the 4 minutes, go ahead and unpause it so you guys can see the correct answer. Okay, go ahead and pause the video now. Okay, here we go. This is the correct rule that you should have come up with. Okay, so first what I did was figured out that the difference between them, by looking at the numbers, I figured out that it's going down by 14. So from here to here, it's minus 14, minus 14, minus 14, minus 14. Since they're all the same, that tells me that there is a rule I can figure out, right? They're all going down by the same number. It's an arithmetic sequence. So here's what I started. I started with f of 1 equals 155. Since I know that it's going down by 14, I put minus 14. But since in the first one you're not actually subtracting anything, I multiplied it times 0. F of 2 equals 155 minus 14 once again, but this time you are taking it away, so it's minus 14 times 1. 114 that you're decreasing. In the next one you're decreasing by 14 and then another 14, so there's 2 of them. And then this one 3, and in this one 4. Using this, noticing that they're all the same, the rule is 155 minus 14 times a number, and this number is always 1 less than that number, right? If this is 1, that's 0. If this is 2, this is 1. So it's 155 minus 14 times 1 less than n is n minus 1. And that is your correct rule. Okay, let's move on to the last 2 problems, number 3 and number 4. The topic here is using a general form to construct rules for arithmetic sequences. So what I want you guys to do is highlight construct rules, which is exactly what we just did in the last example. The difference here is that we're using what we call a general form. So highlight that too. General form to construct rules. What does that mean? It means that there is a shortcut. There is a formula we can use to come up with a rule, so we don't have to go through the entire process like we did here. Okay, we want to make it shorter, we want to make it smaller, we want to make it easier for us to come up with the correct rule. So I want to come up with the rule, and there is a formula for it, which is the one we're going to use. Now let's highlight the formula, and what I'll say about the formula is that I want you guys to memorize it. Okay, so start working on memorizing that formula. F of n equals f of 1 plus d times n minus 1. F of n equals f of 1 plus d times n minus 1. Now, I need you to identify what this means. F of n means the nth term. That means that I can find any term. If I know this rule, I can find any term in my sequence, the nth term. Equals f of 1, the first term, plus d is the common difference, meaning what is it going up by or going down by, times n minus 1. Okay, so here's how you're going to start all these problems. You're going to first find 2 things. The 2 things you're going to find are f of 1. So look at the sequence that you have and find f of 1, and find d. Those are the 2 things you're going to need every single time. That's the first thing you should do. F of 1, look at your sequence. What is f of 1? What is the first term? 100, right? D, the common difference. That means what is it going up by or down by from one number to the next? Let's investigate that. From 100 to 88, it is not going up, it's going down, so it's negative. It's going down by 12, right? Minus 12. Let's investigate the rest just to make sure it's the same number always, okay? 88 to 76, it's also going down. It's going down by 12. Okay, seems to be working out. Just the last one to make sure. 76 to 64, it's going down by 12 again. So minus 12. So that means that your common difference is negative 12. That's D. D is the number that it's going up or down by. Okay, just look at the sequence and try to figure out what is it changing by. That's D. At that point, you're basically done. Okay, here's what you're gonna do. You're gonna write your general form, this one that I need you guys to memorize. For now, keep looking at your notes to use it. F of n, let's fix that, looks ugly. F of n equals f of 1 plus d times n minus 1. What I'm going to do is replace f of 1, which means the first term, plus d, which is the common difference, times n minus 1. Here's what I'm going to do. I'm going to take out this f of 1 and replace it with 100. Because according to this, f of 1 is 100. The first term is 100. I'm going to take out d and replace it with negative 12. Because the common difference is negative 12. So once I do that, I'm done. It looks like this. F of n equals f of 1, 100, the first term, plus negative 12. I'm just going to write minus 12 times n minus 1. And that is your rule. You found the explicit rule. Okay, if you got a little confused, that's okay. Let's do it again. Let's go to number 4 and watch how it's done again. Remember, the first two things that you need to find are f of 1 and d. That's what you care about right at the beginning. Okay, so here's the next sequence, 0, 8, 16, 24, 32. Two things you need to find first, f of 1 and d, right? Always find those two things first. F of 1 means the first term, so the first term is 0. Perfect. D means the common difference. What is it changing by? So if you look at these, it's changing by, it's going up, first of all, so it's positive. It's going up by 8, right? Plus 8, plus 8, plus 8, plus 8. So D is 8. Positive 8. And now what you're going to write is your general form, which I want you guys to memorize. Look at your notes for now, but I need you guys to memorize it. F of n equals f of 1 plus d times n minus 1. That is the general form. Memorize it. So here's what we're going to do. I'm going to substitute f of 1 with 0. So f of n equals 0 plus d. I'm going to change d to 8 plus 8 times n minus 1. Now this is correct. Although if you look at it, we're adding 0. So can we just cross it out? Yes. Since you add 0, it doesn't change it. So it's actually f of n. F of n equals 8 times n minus 1. There you go. That's much better. Both are correct, by the way. This one's correct and this one's correct. It's just that this one is you're adding 0, so it just looks weird. It looks awkward. Okay, so this one is much preferred. All right, so I want you guys to go to your side and try the last two problems. Okay, actually just one problem, number 2. So go ahead and work on number 2 on your side, please. As before, pause the video right now. Do not continue watching it. Just pause. Try it yourself. Take about 4 minutes to do it, and then once you're done with the 4 minutes, go ahead and watch the correct answer. Okay, so pause video now. Okay, here is the correct answer for number 2. Got an explicit rule for the arithmetic sequence 6, 16, 26, 36. First thing you always do is find f of 1 and d. F of 1, the first term, is 6. D, the common difference, is 10. So it's going up by 10, by 10, by 10. So I'm going to use the general form, which I want you guys to memorize. F of n equals f of 1 plus d times n minus 1. F of 1 is 6, right? So I put in a 6 right there for f of 1. And then d is 10, so it's 10 times n minus 1. And there is your general rule. And you're done. Okay, so we're done with the notes. What I want to point out is the homework. It's page 142, number 1 through 15. Whoops, let me fix that. It's page 142, number 1 through 15. And then it says, do not do recursive rules. What I mean by that is a lot of the problems on the homework says, write the explicit and the recursive rule. you have not learned recursive rules. All we did was explicit rules. So basically, just do everything the way we did it in class in the notes. Okay, so don't worry about where it says recursive rules. You have not learned that. Okay, all right, I'll see you guys tomorrow.